Hi everyone. In this video we're going to be talking about the empirical rule, which we cover in chapter 3 of our textbook, but we need to go over a little bit more details in terms of the applications and that sort of thing. So that's really the purpose of these two videos that we're going to be looking at here. So the empirical rule is known by another name, right? It's the 68, 95, 99.7 rule, and it's a nice sort of shortcut, if you will. It isn't exact, it's approximated, and we'll see that a little bit more carefully actually in chapter 6 when we talk a lot more about something called the normal distribution, which is what the empirical rule is based on. So the beginning of this is really premised in the fact that we're dealing with a distribution, okay, like the one on the screen here, that is symmetrical, okay? So it's symmetrical about 0 here in the middle, and actually the thing that lives here is the mean, right, x bar. And it also has the feature that this is also the median and the mode. All three are the same in this distribution. So it's symmetrical, it's two-tailed, one peak, all that good stuff, and that's very, very important. And the numbers that are on the bottom here, these are actually standard deviations, okay? Very important we understand that. So standard deviation, remember, was the average distance a data value is from the mean. And so looking in this, really the section, right, in the textbook talks about measures of relative position or relative standing. And so that's what we're concerned with. Where do things sort of rank? And that's what we're looking at here. Now you might be wondering, how do we know that 68%, 95, 99.7 rule, where do those numbers come from? And the answer involves some mathematics. So believe it or not, okay, this particular function that you see here, the scary looking thing, is actually what produces this graph, okay, and understanding this distribution. And we've got something called a standard normal distribution, and this is where we let the average, the mu, be 0, okay, and the standard deviation be 1. And again, this gives us this picture, right, because again, we let x bar, the mean, be at 0, right? How far are you from yourself? 0. Distance is 0 away. Now, when we put in mu equals 0 and sigma equals 1, we actually get a nicer looking function here, okay? We call this one the standard normal distribution. And that's, again, important in chapter 6. But the reason I bring this up is because in order for us to get these percentages, okay, the 68, 95, 99.7 rule, we actually need calculus, okay? So there's the integral. So in Calculus 2, we talk about the integration, and a little bit in Calculus 1 as well. And so what it really focuses on is, in this notation, is finding probabilities. And I know we're not talking about probability yet, but the essence here is that we take the integral of this large complex function that's scary up here, okay? And so that's really the idea behind this. So when we take these areas, okay, between certain values, that's what gives us these percentages, 68%, 95, 99.7. You can also treat them as 0.68, 0.95, or 0.997 as a decimal. We know under the area under the whole curve is 100% or 1. That's important to remember. So these are the three numbers that you really just need to walk away with kind of remembering here. Okay, what we're going to look at next is a set of examples. So we'll work probably two more in this video, and then we'll save the other ones for the second video. So we have an exam, a little typo there, but ignore that. So we've got an exam that has an average of 83, okay, and standard deviation is 2.5. And so we want to use the empirical rule to estimate the percentage of students who have scores, and then you fill in the blank. So we got these different ones listed here. Okay, so what's nice is I've got the picture ready to go. And what I want to do in this first one is make sure that you're okay with how I've set this up. So the first thing is we have to remember that the normal distribution, it speaks in standard deviations. And so you'll notice here I've got things nicely labeled as the standard deviations, okay? Now, what's also important about this is I have also included the scores right below them. And so that's important when you do these kind of problems, that you kind of put both pieces of information on there so that way you're able to read it a little bit more easily. Now, the first thing I want you to notice is that in the middle here is the mean, which is x bar. Now everybody wonders, well, how did you get 85.5? Well, what you do is you look at this from one standard deviation away. Well, we know what one standard deviation is. It's 2.5, okay? Then to get to the second standard deviation, you add another 2.5, or 2 times the standard deviation, and then you do it again. Okay? And to get the other direction, instead of adding it, you subtract it each time. Okay? And so we subtract all of these, and that gives us the 75.5, the 78, the 80.5. So we're subtracting that standard deviation. Now it's 2.5 in this example. I could look at another example and the mean could be different. The standard deviation could be different. So it just depends, okay? And as a result, you're also going to change the context of the problem. So in this case, we're looking at scores. In another problem, maybe you're looking at lengths of time, like days, okay? So it just depends. So anyway, this is how we obtain all of those values that live on the axes here. Now in our case, we're looking for scores, or the percentage rather, that's between scores of 80.5, okay, so that's here, and I like to draw little lines to kind of mark the boundaries, between 80.5 and 85.5, so that would be here. Okay, well, something we should notice is that, we're interested in this area. Well, that's between -1 and 1 standard deviations away. Well, the empirical rule tells us that that area has to be 68%. So it's a nice and easy one. Okay, let's look at one more. And again, you're going to notice it's the same graph. I provide all the information on the bottom with the standard deviations and the scores. And in this case, we're looking for estimating the percentage of students who have scores that are less than 83. Okay, so 83 is here in the middle, and we want everybody that's less, so that's all of this. Okay, well, this is not a particular value that's part of the empirical rule, okay, but we got to use some common sense here. 83 is the mean, okay, which is right in the center, right? So it splits this graph in half, and so therefore this has to be 50%. Okay, and that should make perfect sense. And what that also means then is if this was worded, what's the percentage of students who have scores that are more than 83, then it would be 50% as well. Okay, you'd be on the right side this time. So this hopefully gets us into the mix of using the empirical rule. In the next video, what we're going to do is we're going to look at the next 4 examples, which get a little bit more complicated and allow us to do some adding and subtracting of the different areas.